Hey guys, I just wanted to do a quick follow-up on the in-out accumulation with the water tank. I want to explain C a little bit more in terms of that overall rate function I came up with. And then I want to talk about D because I didn't go to D. I'm back in Desmos. I like Desmos so much better. The graphing calculator is a little frustrating. We'll practice, don't worry. But I just want to show you a couple things about C and D. This will be fast. So going back, we have our total function here. Was the initial condition plus accumulated rate in minus accumulated rate out. This whole thing about the candidates. So in the graphing calculator, it's hard because you have all these graphs going on at the same time. I created this third equation that I call it was Y3, and it was the in minus the out. Why does this give you candidates? So I want to talk about this. So we found one candidate right here at 6.495. That's when the rate in minus the rate out equals 0. Or in other words, that's where the rate in equals the rate out. And in terms of what's happening in this tank, and you kind of did it in the last discussion, this green graph represents the overall rate. The in minus the out rate gives you overall what's happening. So from 0 to 6.495, my overall rate or my overall derivative is negative, meaning the amount is decreasing. So from 0 to 6.495, the water's decreasing the entire time. That makes sense because if I, now using Desmos, plug in my total function and I find what's happening at time 6.495, I get 525. I started out with 1200. So it makes sense that my overall amount of water decreased during this time. But then look what's happening. The rate in is greater than the rate out, meaning you're accumulating more, meaning the total amount's going up. So from 6.495 up until the next critical point, 12.975, we are gaining water. More is coming in than going out, 12.975. And that's why we get our maximum value at 1697 gallons. And then lastly, we can figure out what's happening at the end of time. And if you look at the graph, we're back negative again. So the overall rate is going back down. Yes, water is still coming in, but more is going out. Our overall rate is negative. And we get an answer at this case of 18. That was our 1310 value. I love Desmos because I can do that. I can create the total function and then just plug in. I don't have to keep finding these, but your calculator doesn't do that. You have to continue to do the math 9 and plug each of them in individually. Okay, so that's why I did the in rate minus the out rate as an equation. Finally, for D, the reason I didn't go over D in the video in the first video is because we'll get to more. This is more of a complex kind of thinking problem. But I'm going to show you the answer right now, just so you have it. It says for T greater than 18, no water is pumped in. So no more water is coming in. So we know T of 18 is equal to 1310. At this point, no more water is coming in. So say goodbye to the in rate. But water continues to be removed. So this part is still a factor. So until the tank becomes empty. So let K be the time at which the tank becomes empty. So I'm looking for T of K. And I know my initial condition is T of 18 plus, and I just want to accumulate find the time when water is done. So from 18 up till K, R of T, R of T dt, I didn't need that. R of T dt. What are you saying? And it should be a minus, not a plus. Come on. What are you saying? You're saying, okay, well, if my water at time 18 is 1310, I want to just keep removing water until some unknown time when I can figure out where the water is empty. So in other words, I already know T of 18 is 1310 minus this accumulation from 18 to K, R of T dt. And yeah, I don't know the time, but what it's saying is I want to know when the tank is empty. In other words, I want to know when the total equals 0. So I want to know when this accumulation equals 0. So then you get this kind of equation. They would give you full credit for that. Or you could do 1310 equals the accumulation from 18 to K, R of T dt. think Desmos can actually deal with this. So if you were to do back to the first one, and we could just find the root of it. Let's see. I think Desmos can handle it. 1310 minus 0 x r of PE dt. Or is it when the tank becomes empty? I want to know when this equals 0. 10.55. Oh, sorry, I have the bottom bound wrong. I knew something was off. 18. There we go. Bam, 29. So at time k equals 29.201. They didn't ask for that because they know your calculator can't do that. Desmos can. They just want you to set up, right? But do not solve an equation. But this is how you would write it and not solve it. You would say, okay, once I know time 18, I no longer have water coming in, just water going out from 18 to some unknown time. And I know that I want that value at that unknown time to be 0. That's what I want. I want the total amount of water to be 0. I want there to be no water left in the tank. So then that's how you get this equation. All right, that's it. More I wanted to stress this part though, why I had this in rate minus out rate as your overall rate. All right.